To get below the ice, a cylindrical unit with spherical closed ends melts downwards through the ice before then rotating on a pivot with a linear actuator pushing a conductive plate outwards to melt a large area of ice around it. Meltwater can be stored as a water source. The conductive plates are constructed using conductor and semiconductor connected in parallel, which maximises efficiency as current passes through the perimeter proportionally, depending on resistance as the temperature increases. The whole system will be insulated using silica aerogel to provide thermal insulation and enclosed in an epoxy coating of Belzona 4311 to protect the station from acidity. The unit itself has lead and hydrogenated boron nanotube layers to protect from radiation exposure above the ice. A small conductive plate can then be used to mount the last few metres to the sea where submersibles can be deployed. Temperature in the base will be at 20 to 25 degrees and the humidity kept below 50%.
We will grow plants using LEDs, including 12,750 square feet of wheat to meet the needs of 24 people. A mycoprotein generator will be used, and GM-modified crops with extra vitamin D and calcium would lessen the effect of low gravity on health. Assuming an average of 1.8 litres of O2 is needed per hour per kilo of body mass, 24 scientists averaging 70 kilos will require 3,024 litres per hour from electrolysis of water. Excess O2 will be needed to achieve atmospheric pressure, and an inert gas such as nitrogen will be needed for the right air proportions. CO2 will be removed using canisters containing powdered lithium hydroxide and will be replaced and discarded. Most electrical energy will be generated by tidal generators from convection currents created by undersea volcanoes via a tethered turbine. Solar panels on the communication satellite and exercise machines used by the scientists will serve as extra sources. We will use a twisted light transmitter and qubits on our geostationary satellite so that we can send fewer signals to Earth, hence save energy. Water will be sucked into this filtration system built inside the walls of the station, then boiled to kill microorganisms before being drunk. Urine and water from boiling feces can produce drinkable water. The dried feces can then be burned as an energy source or used as a fertilizer.
For the most efficient search for life, two types of submersible will be used. The first is a long-distance, low-energy, autonomous underwater vehicle for sonar mapping and basic chemical analysis of the seawater. The other is a remotely operated vehicle, which will build on the AUE's groundwork by going to the most promising locations and searching for life, with onboard sampling, analysis and storage equipment. In the ocean, we expect to find extremophiles, including acid-loving acidophiles and salt-loving halophiles that both survive by maintaining a constant internal pH, and endoliths that could potentially survive below the ocean floor by feeding on the magnesium sulfate and sulfuric acid hydrate present on Europa.